All right. Let's see, what are we doing? Math 35? That's what we're doing, right? Let's do some math 35. Where we left you off is we had you guys, we were in R3. And we had done multiplying polynomials. And I'm hoping you at least looked over your notes or something like that. We're going to be using that stuff today, and we don't have time to go over it again. What we're doing today is we're going to start with division of polynomials, and then we're going to go into factoring. So that's last week. So, division of polynomials. Let's just go big. We're going to learn a simpler way of doing this later on. But I think if we go big now and we just do one example, that'll get you through for what you need to do. And we'll do the hard one. And I think before I do it, I'm going to just do one example of division with regular numbers, no polynomials. Just how do I divide 3 into 328? Just a little side thing. Just because it's identical. The steps are identical to what we did. So remember, we try to do take the thing on the outside, divide it into the first number. Does it go in? If so, how many times? 3 goes into 3 one time. I take this number that I just put up here, I multiply it by that number and write it beneath it, and I subtract. And I get a 0, and then I bring down the next number. Then I go, does 3 go into 2? It does not. I have to put a 0 up here because 3 doesn't go into 2. And then I bring down the next number. Three goes into 28 9 times. 9 times 3 is 27. So I still take that number, multiply it there, and subtract. And I get a 1. And I'm going to stop here. We're not going to do decimals because we're not going to do decimals with polynomials. The way we show this is effectively saying 328 divided by 3 is 109. Then this remainder goes on top is a 1. And this becomes the denominator. 109 and 1/3. That was without variables. It's the exact same thing with variables. Exact same steps. We divide, we put the number up top, we multiply, we subtract.
I cannot hear you.
Really? Is it muted somewhere? Can you hear me now? Do you have mute on? Or you have your volume off? The speaker, my microphone's on.
I should.
Make sure you didn't hit it.
I could hear you before you stopped the recording, and then now I can't. Now that you restarted the class.
Yeah. Everything's on over here on this side. Click it back and forth. Testing. Can anyone else hear me? Oh, well. This is come in person if you can. Don't stay home if you can avoid it. All right, so. Same steps apply to polynomials. We did divide. We did multiply. Okay, someone else can hear me, so it was just divide, multiply, subtract, and then bring down the next number. I say bring down the next thing because it won't be just numbers at this point.
Everything's good now.
Awesome. All right, so we're going to do that here. Now, what I want you to do when you're doing it is, at least on the inside, for every spot that is missing the exponent counting downward, put something in there. I have 8x to the fourth here. The next exponent should be 3 if I'm going downward, but I don't have a 3. So put in a 0x to the third power. The reason why is you'll like it makes the division harder to do if you don't, and there's a good chance you'll fuck it up if you don't. And then I've got plus 12x squared plus 7x minus 18. And now when we do the dividing in step, we're again only focusing on the things in the front. I said focus on the 3 here. I'm focusing on that value there first, and I'm only worried about the x squared. So how many times does x squared go into 8x to the fourth? You can do this if you want on the side. 8x to the fourth divided by x squared. You can do that subtracting of exponents that we were doing, and you get 8x squared. Or you can cancel out or whatever way you're comfortable doing it. And that's what goes up on top. 8x squared goes up on top. That was my division. I am going to take the 8x squared and multiply it now by everything out front. 8x squared times x squared gives me 8x to the fourth. 8x squared times 2 gives me 16x squared. These were both positive. So that was my multiply thing. I did the divide, I do the multiply, and I'm lining it up underneath the other x squared. And now we subtract. I am subtracting both of those. If I subtract both of those, 8x to the fourth minus 8x to the fourth is 0x to the fourth. And then 12x squared minus, we're going to distribute the minus to the 16 also. 12 minus 16 is negative 4x squared. And I didn't have an x cubed here. So that was the subtraction. And I could bring down the rest. I think it's helpful to bring down the rest each time when you're doing division by polynomials, just so you can see where everything's going. Draw a line up here, make sure this is clear that that's the question this semester. And now we're doing x squared into these. Negative 4x squared divided by that x squared. The x squareds cancel out, I'm left with negative 4. So I distribute, I've got negative 4 times x squared is negative 4x squared. And I have negative 4 times 2 is negative 8. So that was the multiply. We got to do the subtract. I got to remember to put a negative sign on this like this and distribute it. So even though they were already negative, I got to distribute that sign. So this will be positive 4x squared. This will be positive 8. If I add vertically, I've got negative 4x squared plus 4x squared is 0x squared. Negative or 7x plus nothing is plus 7x. And negative 18 plus 8 is negative 10. So I don't need the 0x squared here. That's not important anymore. And now my thing on the outside is larger than the thing on the inside, exponent wise. I have an x squared here, I have a 7x here. Exponent on the outside is larger than the inside. So stop. And we start writing down our answer. So I'll write down the problem again, just so we can see what we're doing. And how did we do it with the division? Without the variables? The number on top is the thing that goes out front. So I have 8x squared minus 4. And then rather than like this is really means 109 plus 1/3. We tend to not write that plus sign with mixed numbers. We want that plus sign here for polynomials. So I'm going to say plus. And what was that? The remainder after division is what goes on top. So I have 7x minus 10. That goes on top. And what I divided by, x squared plus 2 goes on bottom. That is how you divide by polynomial. So it's like regular division. We will learn an easier way, and I think it's chapter 1, it might be chapter 2, it's called synthetic division. But for now, this is the review section. This is some of the stuff like we're doing today. You're gonna go, that shit ain't review. I didn't know how to do that. The idea is review. We're gonna take it up a notch. So I'll call it page 1. Give you another couple seconds to write that down. We'll go on to R3. R4. What are we on? R4? R4. Okay, you guys ready? Are you guys excited? This is not the moment you've been waiting for. Factoring. This is when you think algebra, you think factoring. This is what everybody remembers from algebra in high school. Factoring. So I'm just going to go over a list of things we should do. 1, look for the GCF, greatest common factor. And then 2, after we've dealt with the greatest common factor, if there is one, we will count the terms. This may be something that your high school teacher didn't talk about, but there's different strategies depending on how many things there are. If there's 4 terms, we will do it by grouping. If there's 3 terms, this is a trinomial. Some of you have learned the diamond method, shit like that. Different little like techniques people have taught in high school. There's different methods for it. 2 terms is a binomial, so we're looking maybe at binomial, maybe formulas, or just plain. And the reason I mentioned formula, like last Thursday, we talked about a squared minus b squared. It's a minus b and a plus b. So binomial is 2 terms. If we're in this form, we might have something like this. And there might be a special case scenario where we need to do substitutions first. That's probably going to be the new stuff, if you guys have gone through algebra in high school. So substitutions first if necessary. I'll slop that in at the end because it's complicated, and I want to make sure you know how to do all the processes first. Well, let's look at an example. 6a squared minus 18a to the 4th. Now, I don't know if I've talked about my table with you guys, but if I haven't, I'm going to do it here. One way that you can find the greatest common factor, if there is one, is to write down both of these and then factor them. I'm going to do it as a table. And I'm going to keep in my table, columns only have one value. One thing. You see what I mean in a second. So 6 is 2 times 3. And a squared is a times a. Like you can, there's methods to speed this up in a second, but we'll do that then. 18 is 6 times 3. And 6 is 2 times 3. So 18 is 2 times 3. And I'm going to line these up. I'm going to put the 2 underneath the old 2, the 3 underneath the old 3. I have another 3. I don't, this column's already got 1 3 in it. I'm going to make a new column for the last 3. And then it's got 4 A's. I'll put the 2 there, and then I got 2 more. Full columns are the GCF. So that 2 column is full, that 3 column is full. I've got an A in each row there. I've got an A in each row there. The greatest common factor is 6a squared. I'm going to circle them. The reason why is if you do this table, whatever you haven't circled stays in the parentheses. A row with nothing in it gets a 1. So my 6a squared has nothing in it. I'm going to put a 1 there, and I'm going to put the 1 here. And I think it's easier if you don't put the signs in the table and just use the signs as you're going. The 18 had a negative. I'll bring the negative down. Everything that's left over in that row is what stays in the parentheses. 3 times a is 3a squared. Now, once you've got it in parentheses with the greatest common factor, you should keep checking. I have 2 terms, so I'm looking at the binomial list. Is there anything else that might factor? Can I factor those? This does factor, although I wouldn't factor it. But in case the homework does, I'm going to show you it. Bring the 6a squared down. This is 1 squared minus square root of 3a squared. Which is obnoxious. Which means we can apply that formula up here. I can do 6a, I gotta keep the 6a squared, keep writing that down, don't make it disappear. What I've got going on here, if I look at this formula up here, my a equals 1. God, I wish I hadn't used a's in here. A's from the formula equal 1. And b's from the formula equals square root of 3 times a. So if I want to follow the a minus b, a plus b from the formula. I really wish I hadn't used a here. I've got a minus b is 1 minus the square root of 3a. And a plus b is 1 plus the square root of 3a. The homework on the math lab might have you do that. This is technically factored. I would probably stop here. Because radicals start getting unmanageable to work, or unruly to work with. Don't go to sleep. See your eyes shut. Not you, the guy behind you. Okay, let's do one that's a little bit harder. Same idea though. We are going to factor 14x cubed y squared minus 28x squared y cubed plus 21x squared y squared. And I'm going to do the same thing. I'm going to make that table. Now, to make it a little easier, when you do it, you should just do all the coefficients first. And then rather than doing a times a times a times a, then smallest exponent for each variable. And I'll show you what I mean by that in a second. So 14 is 7 times 2. $28 is 7 times 4, and 4 is 2 times 2. And 21 is 7 times 3. Now to make it so my sheet doesn't take up an entire page, rather than doing each x's at one at a time, I'm going to look through my x terms and go, which one has the smallest exponent? X squared is the smallest exponent. I can put an x squared on each of these. And the 14 has another x. And I do the same for the y's. The y squared is the smallest term for each of them. I'll put a y squared on each. And y cubed has an extra y. So my GCF will be my complete columns. I have a 7. I have an x squared. And I have a y squared. Then I'll start doing what's left over. The 7 or the 14x cubed y squared has a 2 and an x. So I got a 2x left over for that one. I'll bring my minus sign down. The 28 has a 2 times 2, which is a 4, and a y. So I got 4y here. And the 21 only has a 3. Now they'll give you some shit like this that's a little more obnoxious. This doesn't factor, I have no exponent, so it can't factor. The homework will give you shit like this. Let's see, x minus 2 cubed minus 16. All right, so same principle. 24 is, that's 6 times 4. And I got 2 times 3 and 2 times 2. So I got a 2, a 3, a 2, a 2. Sixteen is 4 times 4, and we know each of those are 2s. So I need 4 2s. I have a column for 3 of the 2s, and I'll make a new column for the last 2. And finally, 6 is 2 times 3. And now I can see that the reason why I didn't deal with the x minus 2 is because I see it in each term, which means I can pull that out. I have an x minus 2 in common for all of them. The 16 has another x minus 2. And the 24 has another x minus 2 and another x minus 2. My only complete columns here is that 2 and that x minus 2. And what I'm left over with is 3 times 2 times 2 is 12 times x minus 2 squared. And then for the next one, I bring down the minus sign. 2 times 2 times 2 is 8. And I just have a single x minus 2. And in the final row, I just have a 3. So plus 3. It likely won't even have you stop there. The homework might want you to go down even further. So this is x minus 2 times x minus 2. And if you multiply that out with what we were doing on Thursday, you're going to get negative x squared minus 4x plus 4. And there's still a 12 in front of it. So what I'm going to do is I'm going to just like multiply all the stuff out inside the parentheses. And go from there. Twelve times x squared is 12x squared. 12 times negative 4x is negative 48x. And 12 times 4 is 48. That is from that one. Then I've got negative 8 times x is negative 8x. And negative 8 times negative 2 is plus 16. So this stuff comes from that one. And then I'll just bring down my plus 3. All right, so grouping them all together, I still got my 2 and x minus 2 up front. I don't have any x squareds in there except the first one, so I've got 12x squared. And I'll count up my x's. I've got negative 48x and negative 8x is negative 56x. And then I've got plus 48, plus 16, plus 3. We add those up, 48 plus 3 is 51, 51 plus 16 is 67. And this one does not reduce, so that would be where it stops. And we haven't covered how to check for reducing that yet, but that's a shitty one to start with. So I'm not going to start with explaining trinomial on that one, especially since it doesn't work. All right, you guys, ready for more?
Yes.
Startle the shit out of me. Who said you could speak? Does anyone else in here need that longer? Okay, so let's go back to some other stuff. It's a little bit easier, but still factoring. So this example, we're going to have 9y cubed minus 15y squared plus 6y minus 10. So if we look at our list, this has 1, 2, 3, 4 terms. 4 terms said to do it by grouping. There's always 2 combinations you really want to check. You want to generally check these 2 together and these 2 together. Or you want to check the odd ones together and then the even ones together. So put those two together and put those two together. I'm just gonna go with the top one. So what I need to do is factor 9y cubed minus 15y squared separately from 6y minus 10. And as a pro tip, start with the easier shit. Other teachers cuss. I cuss and write it down. Which one of these is easier to factor? This is not a trick question. You guys want to factor that one or this one? The one below? 6y minus 10, I think, is easier. I don't even need to make the chart for this one. What number goes into 6, or what's 6 multiplied as, and what does 10 multiply as? We've got 2 times 3 here, we've got 2 times 5 here. The only thing they have in common is a 2. If I divide 6y by 2 and 10 by 2, I get 3y minus 5. Now, if grouping works, if this putting those two together the way I did works, if grouping works, 3y minus 5 shows up again. And I need my 2 to be positive to make it so it's 6y. So assuming that shows up again, I'm going to put that right here. I'm going to put 3y minus 5 there. And ask, what did I got to take? What did I got to divide by from 9y cubed to get 3y? Or what did I need to divide negative 15y squared by to get negative 5? Or we can just factor it out. If you don't recognize it right away, factor it out. You've got 9y cubed and 15y squared. Write down the factors of each. Remember keeping the columns the same. And then they both have a y squared. And this one has an extra y. The thing I had to factor out was 3 and a y squared. Double check it. Does 3y squared times 3y give me 9y cubed? Does 3y squared times negative 5 give me negative 15y squared? Does 2 times 3y give me 6y? Does 2 times negative 5 give me negative 10? All right, everything good is good to go here. What we're going to do now is we're going to say, look, both of these have a 3y minus 5. What I'm going to do is I'm going to pull that out. and take everything that's left over and throw it in a parentheses. The 3y squared and plus 2. And it doesn't really matter what order you're writing it. You could do 2 plus 3y squared. That's my answer. How can I check that it is correct? Multiply it out. It's exactly correct. Multiply it out. I should get what I started with. You multiply that out, 3y times 3y squared is 9y cubed. And then 3y times plus 2 is plus 6y. I said 9y cubed and I wrote 9y squared. And then if I distribute the negative 5, I got negative 5 times 3y squared is negative 15y squared. And negative 5 times 2 is negative 10. And if I rearrange these in descending order by exponent, I get what I started with. What? Well, you're laughing at me. I'm like, why is she snickering? This shit's not funny. You want funny? I'll give you funny. You want funny? I'll give you. Getting all crazy out here. Give people time to write that down. Maybe I'll give you one to start on. See how far you guys get on your own. And it's gonna be ugly. Let's see. I don't want to use S, so I will use W. Try doing the factoring by grouping on that. The hell is this? They changed the order of the sections. Mother, this is R6 in the homework set. They changed the shit. What is this bullshit? All right, I'm gonna have to double check what a line homework sections line up. I need to redo the syllabus. They changed chapter R. That's some bullshit. I'm like looking at R4 and it's in the home range is integer and rational exponents. We're on R6 though. We did R3 and R4 pretty quickly. We did R5. That was our R3. Right. I guess I need to relabel my lecture notes. No one told me this shit, which means no one's on that current homework set yet. I made it fucking rude, didn't I? Couple different variables. That's fucking dick move. Don't let the variables throw you off. The process remains the same. What do the 5W and the 15 have in common? Just 5, right? If I divide 5W by 5, I get W. If I divide 15 by 5, I get 3. If that works, the W plus 3 shows up again. What do I need to multiply 3 by to get 3R squared? R squared. Let's check that I did it, that works. R squared times W gives me R squared W. R squared times 3 gives me 3R squared. 5 times W gives me 5W, and 5 times 3 gives me 15. That works. So I got the W plus 3 on both of them. I can pull that out front. And whatever's left over gets thrown in parentheses. R squared plus 5. Okay. All right, let's take a look at doing trinomials. 3 terms. I'm going to show you it by example. We'll do it by example. And I'm going to show you it without explaining, and then we're going to work backwards and figure out what we did. Because you're going to call some bullshit on me in just a second. You're going to say, where did you get that, Mr. Jones? And I'm going to tell you, wait 5 minutes and I'll show you. So we're going to start off with 5z squared plus 4z minus 12. That's what we're going to try to factor. And I'm going to tell you that I want to use 5z squared plus 10z minus 6z minus 12. (10z minus 6z is still 4z. So I haven't changed this yet. Now, if I go by grouping, I can pull out a 5z here and it leaves z plus 2. And if I pull out a -6 here, it leaves z plus 2. And doing what we just did with the grouping by terms, I'm going to have z plus 2 times 5z minus 6. That's going to be our answer. Now, if you were comfortable with doing the stuff with grouping when there was 4 terms, then the only hard part here, this is all the 4-term method. The hard part here is going, what the fuck? How did he get from there to there? Right? It's getting from there to there, that's the hard part. This is how you do it. I'm going to say this is in the form, generally we use x's, but I'll use these here. Az squared plus bz plus c. And what we want to look at is look at a times c and b. So if I line these up, I've got a 5 right here, a 4 right here, and a -12 right there. So my A is 5, and my C is -12, and my B is 4. 5 times -12 is -60. So what I'm going to do is I'm going to make a little table. Eventually, and especially if you start recognizing the things that work, you can go faster. With this table is pretty straightforward. It's very organized, and you can't go wrong if you do this table. I need 2 numbers that multiply to a times c, which in this case is -60, and add up to b. Now, if I multiply 2 numbers together and it ends up with a negative number, one of them has to be negative, right? Does this make sense? If I multiply 2 numbers and the outcome is negative, one of them's got to be negative. So that means I'm going to just start with -1 and 60. Those 2 multiply to -60. And I'm just going to add them up. 60 plus -1 is 59. Now what I'm looking for. I'm going to raise this up or lower up right one. I'm going to say -2. How many times does -2 go into 60? 30. 30 plus -2 is 28. And we can keep going down the list. -3 goes in 20 times. -4 goes in 15 times. -5 goes in 12 times. And if I try -6, it goes in 4 times. That's the one we're looking for. But I'm going to keep going a little bit further because I want to illustrate something. -7 doesn't go in. That's a no-go. Neither does -8 or -9, right? -10 divides into 60, leaves behind a 6. And if I add those together, I get -4. Notice that I have kept in just increasing this by 1 here. What has happened to my B column? It keeps going down, right? It goes one direction. In this case, it's going down. So if you're like a long ways away, you're getting like a 59 or a 28, you can go, let me skip some numbers. Maybe I don't need to do 3, 4, and 5. Let me jump up to like -10. And I jumped up to -10, I go, oh shit, -10 is a -4. I went too far. Like, let's say I don't have those lines. What the? I went from 59, I jumped to -10 and 6, and I've got -4. I went too far, but -4 is closer to 7 than the 4 than the 59 is. So just work backwards. If you follow this table, just doing one number increase at a time, you will find it, or you'll show that it doesn't exist, and we'll do one that doesn't exist. So what do we do with this -6? This is, I told you what we needed. That's what we were looking for. What the fuck do I do with it? I'm going to take this -6 and 10, and I'm going to break B up into it. So I had my 5z squared plus 4z minus 12. I'm going to take the 4z and I'm going to split it up into -6z plus 10z. That's what we did right there. Now you don't have to do the table, but it's really helpful. You guys ready for another one? Oh, then we follow the steps we did up here. Hello? You need to rename my goddamn chapter R shit. This makes me mad. All right. Let's go on to, let's try this one. So what we're going to do is we're going to do A times C is 3 times 6. That gives me an 18. My B is -5. That's my target number. We're going to do a little bit of reasoning here to figure out what numbers we're going to use. If I end up with B being negative, and I'm adding two numbers together, the big number has to be negative. Does that make sense? If I'm adding two numbers together and the outcome is negative, the bigger number has to be negative. So I need a big negative number here, negative 18. If it's going to multiply to a positive value, though, the other one has to be negative also. So we let what? Thank you. All right, so -1 and -18 add up to -19. You know what? This isn't going to work the way I did it. I wanted this to be 16. Let's change it real quick. 3 times 16 is 48. So this is going to be -1 and -48, and that'll be -49. Sorry, guys. That was going to be over real quick. All right, let's try the next one. Does -2 go into 48? Yeah, if you put it in a calculator, 48 divided by 2 is 24, and it needs to be negative. These add up to -26. If I put in -3, I know it's 3 and 16 multiplied to 48, so it's got to be -3 and -16. That's -19. -4 goes in 12 times, -12 times. And those add up to -16. And you can use a calculator to speed up this column shit. I know I do multiples pretty well. I've been doing them a long time, but speeds up to use a calculator to figure this out. -5 doesn't work. 48 is not divisible by 5. -6 goes in -8. And it adds up to -14. Notice my values again were going one direction. In this case, they were increasing. And I went right past -15 where it would be. If -15 existed, it would be somewhere between these -4 and -6. -5 didn't work. Since it didn't happen, this is already prime. So the -15 was passed on the table. And that's why I showed going along it in a pattern. You will not, if we go further down, if I just keep making this go up, the next one ends up being -8, -6, and it's just the order backwards. We're never going to hit that 15. So this, if you do this table, it'll show you when it can't factor. This is already fat prime, or DNF means does not factor. The homework is probably going to tell you to say it's already prime if they have a problem like this. But if you like on the test, if you write DNF, that's quicker than writing prime. I'm good with it. Let's do another one. (12t squared minus 5t minus 3). First thing you should look for is a greatest common factor. I didn't do it on this last problem, and that was me being lazy. This one doesn't have a t, so I can't take out any t's. Is there any number that divides evenly into 12, 5, and 3? just one, right? One is pointless. So there is no greatest common factor. So we can go on and do what we were doing. This is A, B, and C. A times C is 12 times -3 is -36. B is -5. Okay. So I need, when I add them together, the outcome is negative, so the bigger one's got to be negative again. And when I multiply them, it's negative also, so there one's negative, one's positive. This adds up to -35. If I do 2 goes into 36, -18 times. And this adds up to -16. And now at some point you're gonna go, these fucking lists are long and tedious, Mr. Jones. How do I go about going faster? All right, so if I'm a long way from my target, -16 isn't all that close to -5. I'm gonna jump a few. Let's go up to like, I don't know, 6 and -6. 6 and -6 add up to 0. So -5 is somewhere in this range. So I know it's not past 6. I'll just go backwards. -5 is closer to 0, so I'll start with a number that's close to this bottom. 5 doesn't go into -36. 4 does though, so I'll try 4. 4 goes into -36, -9 times. If I add those up, I get -5. And I found what I'm looking for. So I didn't save myself a lot of time by jumping ahead, but sometimes you do. Sometimes if you do this table, you got to go down like 12 entries and you're like, God, fuck that. Why, is there a better way? Yeah, jump ahead. Just recognize that, again, B is going one direction. It's either going increasing each time or decreasing each time. So what I do is I leave my A and my C alone. This is 12t squared, and this is -3. And what I do is I take these and I split my -5 up into 4 and -9, plus 4t and minus -9t. And then we do our grouping. I think the second set's easier to work with because there's no t's in one of them. And -3 divides evenly into -9. If I pull out a -3, I'm left with t plus 1. And that's done by doing -9t divided by -3 plus -3 divided by -3. So if I did this right, my t plus 1 appears again. That should be a 3t plus 1, sorry. That was going to just show me that I wasn't right. Although I should have left it. It shows what happens when you fuck up. In fact, I'm going to redo that in a second. I'm going to leave it as I fuck up, and I'll show you what happens when you fuck up. I think the easiest one to work with is go, what do I need to multiply 1 by to get 4t? 4t. Now, always double check. 4t times 3t is 12t squared. 4t times 1 is 4t. Negative 3 times 3t is negative 9t. And negative 3 times 1 is negative 3. Finally, I have the 3t plus 1 in both groups. I will pull that out. And what's left over goes in the parentheses, 4t minus 3. I don't have anything squared or anything like that. I don't need to keep checking. Sometimes it factors more. In this case, I have no exponents of 2 or higher, so I'm done. Now let me backpedal and just show you what happens when you fuck up. When you fuck up like heavy guys. Notice when I first started doing that, I said negative 3 and then t plus 1. I missed the 3. I knew what I was doing and I went too fast. I wrote down wrong. And I said t plus 1, this parentheses needs to repeat. And then I said, this is exactly what I did. I said, what do I need to multiply 1 by to get 4t? And I said 4t. That's all fine and dandy. Now when I check though, 4t times t is 4t squared, not 12t squared. It should have been 12t squared. That would have told me right away, this is wrong. Effing stop. For some reason, I'm okay writing fuck, but I don't want to write fucking. Interesting. What? It's an odd line to draw. Don't keep going and just go, it's all fine. Go back and go, what did I do wrong? This tells me I was wrong. Go back and find your mistake. So it helps even along this. That's why I've shown it every time. When I did the factoring out, I multiplied it back through every single time before I continued doing the factoring. Because I wanted to make sure I did that step right, because it's the one that's the easiest one to mess up. It's really easy to mess up. You guys ready for one? Yeah.
Obviously, this is really quick. Do you care if you don't do it like that? I got the same answer, but
No, as long as you factor and get it correctly, I'm okay. The table is optional. How do you do it?
why they're gonna what I'm like the problem, and then I do my 4 parentheses, and then I do like okay,
Like
so
guessing.
T, I do 4t for one parenthesis, and the other one I do 3t, and then I was like, okay, how do I get -3?
Let's discuss this, because this is something the book does, and I agree with you. So this is a useful tool. This was the problem we were doing.
Yeah.
And she said, well, maybe one of them's got 4t and one of them's got 3t. Those multiply together to make 12t squared, right? Well, what if you had not started there? What if you had started with 2t and 6t? How many combinations do you got to go through before you try out all of these combinations and find out none of them work?
4, because I would do like 1 times -3.
Okay. What if this isn't -3, but this is like 15 or 20 or a larger number that has things that break down? You can get, if you did that, the same idea on this one right here. We just did this a second ago. This one actually, that one's pretty easy to go what the parentheses got to do. The problem is figuring out what combination goes in there. And so it's gonna take you probably longer to guess and check. If you do guess and check, that's fine, but realize you may end up wasting a lot of fucking time and not figure it out. You're gonna have a really hard time guessing and checking on this one, because you ain't gonna find shit. Especially if that's not a 3 and that's like a 16 or something where there's a lot of ways to break it down. Guess and check works. And can be faster. The more practice you have with it, the faster you go. Like, I think it's like this. So guess and check work, it can be faster, but if you can't figure it out with guessing and checking in like 2 minutes, fucking scrap that. Don't do that. If you obviously have more things to do, scrap it. If you waste more than a couple minutes, use another method. The table is my thing. I like it because it keeps it organized. No one teaches it that way, except me. I've never seen anybody teach it that way. High schools teach like a diamond method, which is really just a form of guess and check. Do they put A times C on top or and B on bottom, or the other way? They put those here and go, what do I got to put in here? Which is a guess and check. It's still a guess and check method. The table will make it so you find it, but again, it's long. It can be long. The guess and check is fast, but it can be like, so where she was going with this one is I've got 4t and I've got 3t. And I know I need to end up with -5. And what I'm really trying to do is, what are the different combinations I can do with -3? And I'm only writing them all out to show all the combinations. You wouldn't do this in your guess and check method. I could do, let's see, I could do +1 here and -3 here. I don't even have that many approaches to it. Yeah, I do. I could do -1 here and +3 there. I could do +3 here and -1 there. Or I could do -3 here and +1 there. Those are the only ways that 4t and 3t go to 12t squared and -3 breaks down. And now what you have to do is you literally just go through and multiply it, hopefully quickly, and figure out which one gives you this. So this gives me 3 and -12. That gives me a -9t, that's out. This is 12 times 3 is 12t minus 3t. This is a +9t, that one's out. 3 times 3t is 9t, -1 times 4t is -4t, this is 5t. That's not right, but if you find the positive version, it just means you have those signs wrong. So flip the signs, you do this one out, you get -5t. And bam, that's your combination. And you don't even have to do the grouping, you're already at the final answer. So the guessing works. Try doing that shit on this one without knowing what the answer is. You got to do a lot of combinations. It's even worse if it's something like 12t squared minus 14t plus, I don't know, let's put a big, let's make it a negative. Let's fucking really throw it off, like -60 or something like that. I don't know if -60 works. I'm just saying, trying to do the guess and check here, you're going to be at it for probably time. So if you do that, you find big numbers, only waste a couple of minutes on guess and check if you like guess and check. Let me give you guys another one. Is there a greatest common factor here? This doesn't have an X in it, so I can't take out an X. Do these three numbers have a number in common? Three. Pick the one that's like got the fewest numbers to check. 15 is 3 times 5. Just check to see if the other two are divisible by 3 or divisible by 5. In this case, they're both divisible by 3. So if I divide everything by 3 and I put it on the outside, I get 8x squared plus 14x plus 5. Now, the guess and check method here, you could try x with 8x or 2x and 4x. I'm not going to go with the guess and check method because I think most people are experienced. If you've done any algebra in high school, your teachers taught you the guess and check method. That's what they did. They weren't math teachers. They taught elementary school or high school. It's true. You don't need to have math degree to teach in high school. So they're good at they're good, reasonably good at everything, but not an expert at anything. Well, you know what I mean. All right, so my A times C is 8 times 5, and that's 40. B is 14. This is where guessing and checking also comes in right here. I don't need the table. If I can look at those numbers and go, what multiplies together to make 40 and adds up to 14? Ten and 4, right? Okay, so if you spot that, if you spot 10 and 4 right away, you don't have to do that table shit. So the guess and check, or like if something looks familiar, run with it there, don't do the table. Bypassing all of that, I'm going to bring that 3 down. I'm going to have my 8x squared and my 5. And I'm going to split up my 14x into plus 10x and plus 4x. So this is where like guessing and checking can speed it up without being stuck. You see what I mean? Like if it doesn't factor, you're going to be out, especially with large numbers, you'll be at it forever. You're going to be, yes, I should do that. That's fucked up. I bet the homework has one like that with big numbers and it just doesn't factor, and you could guess and check forever. All right, let's put them together. Don't forget to bring that 3 down. The 3 is part of the answer. It doesn't go away. So, well, maybe I'll make this a bracket here. I'm going to do the one on the right first. Does 4x and 5 have anything in common? No. So that one just comes down as is. And since I know I need to do this grouping thing, I'm just going to put a +1 in front of it. The 4x plus 5 should repeat. What do I need to multiply 5 by to get 10x? 2x, right? So my answer will be, don't forget to have the 3. I have the 4x plus 5 on both of those. I pull that out. And what's left over is the 2x plus 1. Now I bypassed checking my math real quick and going back and making sure I didn't fuck that up. Because I've done it 3 or 4 times and for lectures purpose. Wanted to keep going on with the topic. But at this point, you could multiply it back out and get it. Yeah,
That 3 is multiplying to both of the parentheses, not this.
it only multiplies 1. It only needs to go into 1. That's a really, really good question. Bennett, right? So Bennett goes, do I gotta do this into both of them? Let's check it. If I put it in both. Three times 4x is 12x. 3 times 5 is 15. 3 times 2x is 6x. And 3 times 1 is 3. Now, rather than starting off with the hardest one there, 12x times 6x, does 15 times 3 give me the 15 that I started with? So, this didn't work. It only has to go into one. It would only be in one of them. You could have had 12x plus 15 times 2x plus 1. Or you could have had 4x plus 5 times 6x plus 3. The problem here, and this is if you did, this is, you would get one of these two answers if you did not remember to look for the GCF. Now, I don't know if the homework will tell you that you're close, but like you missed something. I think the homework is going to tell you, wrong. Okay. You've done all this part right. If you got to this point, you've done all right. You just didn't recognize there's more factoring. You can still factor at this point. You could go, oh, look, both of these are divisible by 3, and you could factor out a 3 at this point. Or you could recognize, oh, shit, 6 and 3 are multiples of 3. I could factor out a 3 here. But if you don't do the GCF at some point, it's going to tell you it's wrong. And these numbers are a bitch to work with over here with the 3 in it. 24 times 15 is 360, and you're looking for shit that adds up to 442. That's if we didn't factor out the 3. You see how ugly that shit is? That's ugly. So try. Always look for a greatest common factor. Especially if you start doing that and go, oh, hell no. Like if you're looking like that, you're gonna fuck that. It probably means you didn't factor out something in the first place that would help you. I look at that, nope, fuck that, I ain't doing that. That's a lot of combinations. I don't want to start at 1 times 360. I could probably jump ahead to like 36 times 10. And I could jump around, but it's gonna take a while. These are binomials and that. I don't want to start that stuff yet. So maybe we'll just call it a wrap 10 minutes early. And I will add this part to Wednesday's lecture. And I am going to have to look at the fucking syllabus and look at my math lab and re-change where the R shit is. That's my bad. But I have a class from 5 to 7, so I ain't gonna get till it's at least 7:30. I'm gonna check the homework connect and try to fix it. And so it's. Have a good day, guys.
Have a good day.
You too.